Hello, this is Miss Malatin, and today we're going to talk about moles and volume. The question here is, what is the volume of 2.6 moles of chlorine gas at standard temperature and pressure? And that's what STP means. And until we get to the ideal gas law, we can assume that we are going to be at standard temperature, which is 0 degrees C, and standard pressure for all these problems until it is different when we get to the ideal gas law. So we have here, we do what we always do. We start by writing the initial quantity with units so we know where we start, and the final units, we know where we want to go. Now moles, we have three relationships we can consider with moles. We can consider 1 mole, the mass of 1 mole. We know 1 mole of a gas at STP. We know the volume. And we also know how many molecules are in 1 mole of this chlorine gas. Well, today we're going to use the relationship that 1 mole of chlorine at STP is 22.4 liters. And it looks like we're going from moles to liters, and it looks like this conversion will take us directly there, so we can do a one-step conversion problem. Now this box represents our conversion factor, and we want to cancel moles, and we want to go to the volume. This way we cancel the moles and we have liters of the chlorine gas. And then we can fill in our numbers. Well, 22.4 liters is 1 mole of Cl2. So our next step is to do the math, where we would multiply across the top 2.6 times 22.4, and then hit enter, and then multiply across the bottom. This time we only have 1, and we all know we have nothing here. That's why I put my smiley face. 2.6 times 22.4 divided by 1. My answer is 58.24 in the calculator. I started with 2 sig figs, so I'm going to end with 2 sig figs. 1, the 5, 2 sig figs, the 8, and then that 2 will not make the 8 round, so I will have 58 liters. And that is a one-step moles and volume. The second kind of problem we're going to look at today is when we are given the mass and we need to go to volume. So what is the volume of 12.4 grams of oxygen gas at STP? Well, I'm going to start with the initial quantity with units, and then the units for the quantity they're asking us for. Now we know where we're starting and where we're going. We can consider these three relationships. We know we can convert from moles to mass, moles to volume, and moles to number of molecules. Well, here it looks like we need to go from grams to moles, because we have mass to moles, and then moles to volume in order to make our trip all the way. So let's give this a try. I'm going to do 2 conversion factors. I'm first going to put in my units so I know I'm putting in the correct number. Grams is what I want to cancel. Liters is what I want to go to. My relationship in our conversion factor, I know how many moles there are in a certain number of grams. Actually, 1 mole, I know how many grams there are. And I know 1 mole how many liters there are. Let's fill these guys in. 1 mole of O2 is 32 grams. Where did I get that? That's from the molar mass. We have O2, so we take the molar mass off the reference table, off our periodic table, multiply it by 2, get 32 grams. So that's 32 grams. And also we know 1 mole of O2 at standard temperature and pressure is 22.4 liters. And if you ever forget that, It is right here, volume of 1 mole of any gas at STP, 22.4 liters. That's on the first page of your chemistry reference table where everything is. So I'm going to go right here, 22.4 liters. I'm going to check my units. The grams cancel, the moles cancel, and I'm left with the units that I desire. So in order to do the math, I multiply across the top, 12.4 times 1 times 22.4. I hit the enter. I multiply across the bottom, 32 times 1, and then I divide those two products, and I get 8.68. Now this is a really nice one. I started out with 3 significant figures, and my calculator has 3 significant figures in it. So there we go. I hope this helps you out.